In Python, what are metaclasses and what do we use them for? A metaclass is the class of a class. A class defines how an instance of the class, i.e., an object behaves, while a metaclass defines how a class behaves. A class is an instance of a metaclass. While in Python you can use arbitrary callables for metaclasses like gerub, shows. The better approach is to make it an actual class itself. Type is the usual metaclass in Python. Type is itself a class. And it is its own type. You won't be able to recreate something like type purely in Python. But Python cheats a little. To create your own metaclass in Python you really just want to subclass type. A metaclass is most commonly used as a class factory. When you create an object by calling the class, Python creates a new class when it executes the class statement by calling the metaclass. Combined with the normal underscore underscore init underscore underscore and underscore underscore new underscore underscore methods. Metaclasses therefore allow you to do extra things when creating a class. Like registering the new class with some registry or replace the class with something else entirely. When the class statement is executed, Python first executes the body of the class statement as a normal block of code. The resulting namespace addict holds the attributes of the class to be. The metaclass is determined by looking at the base classes of the class to be. Metaclasses are inherited at the underscore underscore metaclass underscore underscore attribute of the class to be, if any, or the underscore underscore metaclass underscore underscore global variable. The metaclass is then called with the name, bases and attributes of the class to instantiate it. However, metaclasses actually define the type of a class, not just a factory for it. So you can do much more with them. You can, for instance, define normal methods on the metaclass. These metaclass methods are like class methods in that they can be called on the class without an instance. But they are also not like class methods in that they cannot be called on an instance of the class. Type underscore underscore subclasses underscore underscore is an example of a method on the type metaclass. You can also define the normal magic methods, like underscore underscore add underscore underscore, underscore underscore adhere underscore underscore and underscore underscore getItr underscore underscore, to implement or change how the class behaves. Here's an aggregated example of the bits and pieces. Classes as objects. Before understanding metaclasses, you need to master classes in Python. And Python has a very peculiar idea of what classes are, borrowed from the Smalltalk language. In most languages, classes are just pieces of code that describe how to produce an object. That's kinda true in Python too. But classes are more than that in Python. Classes are objects too. Yes. Objects. As soon as you use the keyword class, Python executes it and creates an object. The instruction creates in memory an object with the name object creator. This object, the class, is itself capable of creating objects, the instances. And this is why it's a class. But still, it's an object. And therefore, you can assign it to a variable. You can copy it. You can add attributes to it. You can pass it as a function parameter. E.g., creating classes dynamically. Since classes are objects, you can create them on the fly, like any object. First, you can create a class in a function using class. But it's not so dynamic, since you still have to write the whole class yourself. Since classes are objects, they must be generated by something. When you use the class keyword, Python creates this object automatically. But as with most things in Python, it gives you a way to do it manually. Remember the function type? The good old function that lets you know what type an object is. Well, type has a completely different ability. It can also create classes on the fly. Type can take the description of a class as parameters and return a class. I know. It's silly that the same function can have two completely different uses according to the parameters you pass to it. It's an issue due to backward compatibility in Python. Type works this way. Where name of the class, basis, tuple of the parent class for inheritance, can be empty. Address, dictionary containing attributes, names and values, e.g., can be created manually this way. You'll notice that we use myShinyClass as the name of the class, and as the variable to hold the class reference. They can be different, but there is no reason to complicate things. Type accepts a dictionary to define the attributes of the class. So, can be translated to and used as a normal class. And of course, you can inherit from it. So, would be. Eventually, you'll want to add methods to your class. Just define a function with the proper signature and assign it as an attribute. And you can add even more methods after you dynamically create the class. Just like adding methods to a normally created class object. You see where we are going. In Python, classes are objects. And you can create a class on the fly, dynamically. This is what Python does when you use the keyword class. And it does so by using a metaclass. What are metaclasses finally? Metaclasses are the stuff that creates classes. You define classes in order to create objects. Right? But we learned that Python classes are objects. Well, metaclasses are what create these objects. They are the classes. You can picture them this way. You've seen that type lets you do something like this. It's because the function type is in fact a metaclass. Type is the metaclass Python uses to create all classes behind the scenes. Now you wonder why the heck is it written in lowercase and not type? Well, I guess it's a matter of consistency with str, the class that creates strings objects, and int, the class that creates integer objects. Type is just the class that creates class objects. You see that by checking the __class __ attribute. Everything, and I mean everything, is an object in Python. That includes ints, strings, functions and classes. All of them are objects. And all of them have been created from a class. Now, what is the __class __ of any __class __? So, a metaclass is just the stuff that creates class objects. You can call it a class factory if you wish. Type is the built-in metaclass Python uses. But of course, you can create your own metaclass. The __metaclass __ attribute. In Python too, you can add a __metaclass __ attribute when you write a class. See next section for the Python 3 syntax. If you do so, Python will use the metaclass to create the class foo. Careful. It's tricky. You write class foo object first. But the class object foo is not created in memory yet. Python will look for __metaclass _ in the class definition. If it finds it, it will use it to create the object class foo. If it doesn't, it will use type to create the class. Read that several times. When you do, Python does the following. Is there a __metaclass _ attribute in foo? If yes, create in memory a class object. I said a class object. Stay with me here. With the name foo by using what is in __metaclass __ If Python can't find __metaclass __ it will look for a __metaclass _ at the module level. And try to do the same but only for classes that don't inherit anything. Basically old-style classes. Then if it can't find any __metaclass __ at all, it will use the bars the first parent own metaclass, which might be the default type, to create the class object. Be careful here that the __metaclass attribute will not be inherited. The metaclass of the parent bar __class __ will be. If bar used a __metaclass attribute that created bar with type and not type __new __, the subclasses will not inherit that behavior. Now the big question is, what can you put in __metaclass __? The answer is something that can create a class. And what can create a class? Type. Or anything that subclasses or uses it. Metaclasses in Python 3. The syntax to set the metaclass has been changed in Python 3. i.e., the __metaclass attribute is no longer used in favor of a keyword argument in the list of base classes. The behavior of metaclasses, however, stays largely the same. One thing added to metaclasses in Python 3 is that you can also pass attributes as keyword arguments into a metaclass. Like so. Read the section below for how Python handles this. Custom metaclasses. The main purpose of a metaclass is to change the class automatically when it's created. You usually do this for APIs, where you want to create classes matching the current context. Imagine a stupid example, where you decide that all classes in your module should have their attributes written in uppercase. There are several ways to do this. But one way is to set __metaclass __ at the module level. This way, all classes of this module will be created using this metaclass. And we just have to tell the metaclass to turn all attributes to uppercase. Luckily, __metaclass __ can actually be any callable. It doesn't need to be a formal class, I know. Something with class in its name doesn't need to be a class. Go figure. But it's helpful. So we will start with a simple example. By using a function. Let's check. Now, let's do exactly the same, but using a real class for a metaclass. Let's rewrite the above, but with shorter and more realistic variable names now that we know what they mean. You may have noticed the extra argument CLS. There is nothing special about it. __new__ always receives the class it's defined in as the first parameter. Just like you have self for ordinary methods which receive the instance as the first parameter, or the defining class for class methods. But this is not proper OOP. We are calling type directly and we aren't overriding or calling the parents __new__. Let's do that instead. We can make it even cleaner by using super, which will ease inheritance because yes, you can have metaclasses inheriting from metaclasses, inheriting from type O. And in Python 3, if you do this call with keyword arguments like this, it translates to this in the metaclass to use it. That's it. There is really nothing more about metaclasses. The reason behind the complexity of the code using metaclasses is not because of metaclasses. It's because you usually use metaclasses to do twisted stuff, relying on introspection, manipulating inheritance, vars such as __dict__, etc. Indeed, metaclasses are especially useful to do black magic, and therefore complicated stuff. But by themselves, they are simple. Intercept a class creation. Modify the class. Return the modified class. Why would you use metaclasses classes instead of functions? Since __metaclass __ can accept any callable Why would you use a class? Since it's obviously more complicated? There are several reasons to do so. The intention is clear. When you read operator metaclass type, you know what's going to follow. You can use OOP. Metaclass can inherit from metaclass. Override parent methods. Metaclasses can even use metaclasses. Subclasses of a class will be instances of its metaclass if you specified a metaclass class. But not with a metaclass function. You can structure your code better. You never use metaclasses for something as trivial as the above example. It's usually for something complicated. Having the ability to make several methods and group them in one class is very useful to make the code easier to read. You can hook on underscore underscore new underscore 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 init underscore underscore and underscore underscore call underscore underscore, which will allow you to do different stuff. Even if usually you can do it all in underscore underscore new underscore underscore. Some people are just more comfortable using underscore underscore init underscore underscore. These are called metaclasses. Damn it! It must mean something. Why would you use metaclasses? Now the big question. Why would you use some obscure error-prone feature? Well, usually you don't. Metaclasses are deeper magic that 99% of users should never worry about it. If you wonder whether you need them, you don't. The people who actually need them to know with certainty that they need them and don't need an explanation about why. Python guru Tim Peters. The main use case for a metaclass is creating an API. A typical example of this is the Django ORM. It allows you to define something like this. But if you do this, it won't return an integer field object. It will return an int. And can even take it directly from the database. This is possible because models.model defines underscore underscore metaclass underscore underscore and it uses some magic that will turn the person you just defined with simple statements into a complex hook to a database field. Django makes something complex look simple by exposing a simple API and using metaclasses. Recreating code from this API to do the real job. Behind the scenes. The last word. First, you know that classes are objects that can create instances. Well, in fact, classes are themselves instances of metaclasses. Everything is an object in Python. And they are all either instance of classes or instances of metaclasses. Except for type. Type is actually its own metaclass. This is not something you could reproduce in pure Python, and is done by cheating a little bit at the implementation level. Secondly, metaclasses are complicated. You may not want to use them for very simple class alterations. You can change classes by using two different techniques. Monkey patching. Class decorators. 99% of the time you need class alteration. You are better off using these. But 98% of the time, you don't need class alteration at all. Note. This answer is for Python 2.x as it was written in 2008. Metaclasses are slightly different in 3.x. Metaclasses are the secret sauce that make class work. The default metaclass for a new style object is called type. Metaclasses take three args: name, basis, and dict. Here is where the secret starts. Look for where name, basis and the dict come from in this example class definition. Let's define a metaclass that will demonstrate how class calls it. And now, an example that actually means something. This will automatically make the variables in the list attributes set on the class and set to none. Note that the magic behavior that initialist gains by having the metaclass init underscore attributes is not passed onto a subclass of initialist. Here is an even more concrete example. Showing how you can subclass type to make a metaclass that performs an action when the class is created. This is quite tricky. Others have explained how metaclasses work and how they fit into the Python type system. Here's an example of what they can be used for. In a testing framework I wrote, I wanted to keep track of the order in which classes were defined, so that I could later instantiate them in this order. I found it easiest to do this using a metaclass. Anything that's a subclass of my type then gets a class attribute _order that records the order in which the classes were defined. One use for metaclasses is adding new properties and methods to an instance automatically. For example, if you look at Django models, their definition looks a bit confusing. It looks as if you are only defining class properties. However, at runtime the person objects are filled with all sorts of useful methods. See the source for some amazing metaclassing. I think the ONLAMP introduction to metaclass programming is well written and gives a really good introduction to the topic despite being several years old already. http://www.unlamp.com/pub//python/2003/04/17/metaclasses.html. Archived at http://web.archive.org/web/20080206005523/http:/www.unlamp.com/pub/a/python/2003/04/17/metaclasses.html. In short, a class is a blueprint for the creation of an instance. A metaclass is a blueprint for the creation of a class. It can be easily seen that in Python classes need to be first-class objects too to enable this behavior. I've never written one myself, but I think one of the nicest uses of metaclasses can be seen in the Django framework. The model classes use a metaclass approach to enable a declarative style of writing new models or form classes. While the metaclass is creating the class, all members get the possibility to customize the class itself, creating a new model. The metaclass enabling this. The thing that's left to say is, if you don't know what metaclasses are, the probability that you will not need them is 99%. What are metaclasses? What do you use them for? TLDR. A metaclass instantiates and defines behavior for a class just like a class instantiates and defines behavior for an instance. Pseudocode. The above should look familiar. Well, where does class come from? It's an instance of a metaclass, also pseudocode. In real code, we can pass the default metaclass type, everything we need to instantiate a class, and we get a class. Putting it differently, a class is to an instance as a metaclass is to a class. When we instantiate an object, we get an instance. Object #instantiation of class #instance. Likewise, when we define a class explicitly with the default metaclass type, we instantiate it. Type object. Object. #instantiation of metaclass #instance. Put another way, a class is an instance of a metaclass. Isinstancy object. Type true. Put a third way, a metaclass is a class's class. Type object == type true. Object __class__. When you write a class definition and Python executes it, it uses a metaclass to instantiate the class object, which will, in turn, be used to instantiate instances of that class. Just as we can use class definitions to change how custom object instances behave, we can use a metaclass class definition to change the way a class object behaves. What can they be used for? From the docs. The potential uses for metaclasses are boundless. Some ideas that have been explored include logging, interface checking, automatic delegation, automatic property creation, proxies, frameworks, and automatic resource locking/synchronization. Nevertheless, it is usually encouraged for users to avoid using metaclasses unless absolutely necessary. You use a metaclass every time you create a class. When you write a class definition, for example, like this, you instantiate a class object. It is the same as functionally calling type with the appropriate arguments and assigning the result to a variable of that name. Note: some things automatically get added to the ___dict__, i.e., the namespace, the metaclass of the object we created. In both cases, is type. A side note on the contents of the class ___dict__, module ___ is there because classes must know where they are defined. And ___dict__ and __weakeref__ are there because we don't define __slots ___. If we define __slots we'll save a bit of space in the instances, as we can disallow __dict__ and __weakeref__ by excluding them. For example. But I digress. We can extend type just like any other class definition. Here's the default __repair__ of classes. One of the most valuable things we can do by default in writing a Python object is to provide it with a good __repair__. When we call help repair, we learn that there's a good test for a __repair__ that also requires a test for equality. Obj == evil reprobj. The following simple implementation of __repair__ and __eq__ for class instances of our type class provides us with a demonstration that may improve on the default __repair__ of classes. So now when we create an object with this metaclass, the __repair__ echoed on the command line provides a much less ugly sight than the default. With a nice __repair__ defined for the class instance, we have a stronger ability to debug our code. However, much further checking with evil repair class is unlikely, as functions would be rather impossible to eval from their default __repair__ An expected usage. __prepare__ a namespace. If, for example, we want to know in what order a class's methods are created in, we could provide an ordered dict as the namespace of the class. We would do this with __prepare__, which returns the namespace dict for the class if it is implemented in Python 3. And usage. And now we have a record of the order in which these methods and other class attributes were created. Note: this example was adapted from the documentation. The new enum in the standard library does this. So what we did was instantiate a metaclass by creating a class. We can also treat the metaclass as we would any other class. It has a method resolution order. And it has approximately the correct repair, which we can no longer eval unless we can find a way to represent our functions. Python 3 update. There are at this point two key methods in a metaclass. __prepare__ and __new__. __prepare__ lets you supply a custom mapping such as an ordered dict to be used as the namespace while the class is being created. You must return an instance of whatever namespace you choose. If you don't implement __prepare__ a normal dict is used. __new__ is responsible for the actual creation/modification of the final class. A bare bones, do nothing extra metaclass would like. A simple example. Say you want some simple validation code to run on your attributes. Like it must always be an int or a str. Without a metaclass, your class would look something like. As you can see, you have to repeat the name of the attribute twice. This makes typos possible along with irritating bugs. A simple metaclass can address that problem. This is what the metaclass would look like not using __prepare___ since it is not needed. A sample run of produces. Note: this example is simple enough it could have also been accomplished with a class decorator. But presumably an actual metaclass would be doing much more. The validate type class for reference. Role of a metaclass __call___ method when creating a class instance. If you've done Python programming for more than a few months, you'll eventually stumble upon code that looks like this. The latter is possible when you implement the __call___ magic method on the class. The __call___ method is invoked when an instance of a class is used as a callable. But as we've seen from previous answers, a class itself is an instance of a metaclass. So when we use the class as a callable, i.e., when we create an instance of it, we're actually calling its metaclass __call___ method. At this point, most Python programmers are a bit confused because they've been told that when creating an instance like this instance equals some class, you're calling its __init__ method. Some who've dug a bit deeper know that before __init__ there's __new__. Well, today another layer of truth is being revealed. Before __new__ there's the metaclass __call__. Let's study the method call chain from specifically the perspective of creating an instance of a class. This is a metaclass that logs exactly the moment before an instance is created and the moment it's about to return it. This is a class that uses that metaclass. And now let's create an instance of class _1. Observe that the code above doesn't actually do anything more than logging the tasks. Each method delegates the actual work to its parent's implementation, thus keeping the default behavior. Since type is meta_1's parent class, type being the default parent metaclass, and considering the ordering sequence of the output above, we now have a clue as to what would be the pseudo implementation of type __call__. We can see that the metaclass __call___ method is the one that's called first. It then delegates creation of the instance to the classes __new__ method and initialization to the instances __init__. It's also the one that ultimately returns the instance. From the above it stems that the metaclass __call___ is also given the opportunity to decide whether or not a call to class _1__new__ or class _1__init__ will eventually be made. Over the course of its execution, it could actually return an object that hasn't been touched by either of these methods. Take for example this approach to the singleton pattern. Let's observe what happens when repeatedly trying to create an object of type class _2. A metaclass is a class that tells how some other class should be created. This is a case where I saw metaclass as a solution to my problem. I had a really complicated problem that probably could have been solved differently, but I chose to solve it using a metaclass because of the complexity. It is one of the few modules I have written where the comments in the module surpass the amount of code that has been written. Here it is. The TLDR version. The typeObj function gets you the type of an object. The type of a class is its metaclass. To use a metaclass, type is its own metaclass. The class of a class is a metaclass. The body of a class is the arguments passed to the metaclass that is used to construct the class. Here, you can read about how to use metaclasses to customize class construction. Type is actually a metaclass, a class that creates another classes. Most metaclass are the subclasses of type. The metaclass receives the new class as its first argument and provide access to class object with details as mentioned below. Note. Notice that the class was not instantiated at any time. The simple act of creating the class triggered execution of the metaclass. Python classes are themselves objects, as an instance of their metaclass. The default metaclass, which is applied when you determine classes as metaclass, are used to apply some rule to an entire set of classes. For example, suppose you're building an ORM to access a database, and you want records from each table to be of a class mapped to that table based on fields, business rules, etc. A possible use of metaclass is, for instance, connection pool logic, which is shared by all classes of record from all tables. Another use is logic to support foreign keys, which involves multiple classes of records. When you define metaclass, use subclass type, and can override the following magic methods to insert your logic. Anyhow, those two are the most commonly used hooks. Metaclassing is powerful, and above is nowhere near an exhaustive list of uses for metaclassing. The type function can return the type of an object or create a new type. For example, we can create a high class with the type function and do not need to use this way with class high object. In addition to using type to create classes dynamically, you can control creation behavior of class and use metaclass. According to the Python object model, the class is the object, so the class must be an instance of another certain class. By default, a Python class is instance of the type class. That is, type is metaclass of most of the built-in classes and metaclass of user-defined classes. Magic will take effect when we passed keyword arguments in metaclass. It indicates the Python interpreter to create the custom list through list metaclass. New. At this point, we can modify the class definition. For example, and add a new method and then return the revised definition. In addition to the published answers, I can say that a metaclass defines the behavior for a class. So, you can explicitly set your metaclass. Whenever Python gets a keyword class, then it starts searching for the metaclass. If it's not found, the default metaclass type is used to create the class's object. Using the __metaclass__ attribute, you can set metaclass of your class. It'll produce the output like this. And, of course, you can create your own metaclass to define the behavior of any class that are created using your class. For doing that, your default metaclass type class must be inherited, as this is the main metaclass. The output will be. Here's another example of what it can be used for. You can use the metaclass to change the function of its instance, the class. The metaclass is powerful. There are many things such as monkey magic you can do with it. But be careful, this may only be known to you. Note that in Python 3.6 a new dunder method __init_subclass__cls Quargs was introduced to replace a lot of common use cases for metaclasses. Is called when a subclass of the defining class is created. See Python docs. In object-oriented programming, a metaclass is a class whose instances are classes. Just as an ordinary class defines the behavior of certain objects, a metaclass defines the behavior of certain class and their instances. The term metaclass simply means something used to create classes. In other words, it is the class of a class. The metaclass is used to create the class, so like the object being an instance of a class. A class is an instance of a metaclass. In Python, classes are also considered objects. A class, in Python, is an object. And just like any other object, it is an instance of something. This something is what is termed as a metaclass. This metaclass is a special type of class that creates other classes' objects. Hence, metaclass is responsible for making new classes. This allows the programmer to customize the way classes are generated. To create a metaclass, Overriding of new and init methods is usually done. New can be overwritten to change the way objects are created, while init can be overwritten to change the way of initializing the object. Metaclass can be created by a number of ways. One of the ways is to use type function. Type function, when called with 3 parameters, creates a metaclass. The parameters are class name, tuple having base classes inherited by class, a dictionary having all class methods and class variables. Another way of creating a metaclass comprises of metaclass keyword. Define the metaclass as a simple class. In the parameters of inherited class, pass metaclass equals metaclass underscore name. Metaclass can be specifically used in the following situations. When a particular effect has to be applied to all the subclasses. Automatic change of class on creation is required by API developers. In Python, a metaclass is a subclass of a subclass that determines how a subclass behaves. A class is an instance of another metaclass. In Python, a class specifies how the class's instance will behave. Since metaclasses are in charge of class generation, you can write your own custom metaclasses to change how classes are created by performing additional actions or injecting code. Custom metaclasses aren't always important, but they can be. Metaclass is a kind of class which defines how the class will behave, like, or we can say that a class is itself an instance of a metaclass.